Good morning all. Welcome to Machine Learning video. This is Swapna. Today's our topic is learning rule of first order rules. Learning first order rules. Main our motivation is we need to find the rule representation which are more expressive than the propositional rules. Here that are the more expressive than the propositional rules is first order rules. In inductive learning of first order rules or theories is often referred to as the inductive logic programming ILP. Inductive learning of first order rules. Inductive means every time we are including. While we are learning, we are including. Every time in every step we are including something. So inductive learning of first order rules or theories also referred as inductive logic programming. That means another name is ILP. And these first order rules are generally represented by weaved or implemented by using the programming language Prolog. Whatever the examples are there that are automatically inferred by the Prolog programs. And Prolog is a general purpose Turing equivalent programming language in which programs are expressed as collections of Horn classes. So these set of rules, inductive learning first order set of rules which are expressed as Horn classes in Prolog programming language. These examples are automatically implemented and weaved by the Prolog programming language. In that Prolog programming language, whatever the rules are there that are expressed as Horn classes. So now we are going for what is Horn class and how they are represented, first order rules, and with the example we are going to know. First order Horn classes. Here we are considering to understand this one example. Here we are considering a task learning that simple target concept is daughter x comma y. We are taking the pair of people. One member is daughter of another member. That is our target concept. We need to find that relation between the pairs of people. So in this example, each person is described by some attributes, that is name, mother, father, male or female. Name, mother, father and male or female. So hence training example will consist of the description of people in terms of these attributes along with the value of target attributes. So here we are taking the following positive example. In that we are using the two names or two pair of peoples, Sharon and Bob. And whatever our target concept or target relation is, Sharon is the daughter of Bob. To understand that, here training examples are represented, and within the training example, people are the pair of people is described by the attributes. First person is name 1, Sharon. Her mother name is Louis, and father name is Bob. And male or female also, we are using the two attributes to describe that person. Sharon is female is true, male is false. And next person within that positive training example, second person is name 2, his name is Bob, and his mother name is Nora, father name is Victor, and he is male, not a female. So female false, male true. And also we are specifying with the target concept, that is target concept daughter 1 and 2 is equal true. They has the relation, these pair of people has the relation between each other is daughter relation. That is Sharon is a daughter of Bob. That is, it is represented like this. So whatever the training example is there, by the training example we are representing in the form of rule, means here that is the rule we are specifying like this. If father 1 is equal to Bob and also his name is Bob, and whatever the first people father is Bob and the second person is Bob, the second person name is Bob and first person is female, then we can say daughter 1, 2 is true. So whatever the training example with the description of attributes we saw now, that is given in the form of rule. And in the form of programming language, in the form of first order representation, could learn that from the general rule. Here we are giving with the specific names. That is second person name. Here we are specifying with the particular name, that is Bob. And instead of that, we can use the more general rule with the variables. So to represent this one only, this rule only with the more, with the variables and with the more as a more general rule, if father of y comma x, if father of y comma x and female y, if female y is female, if x is father of y and also y is female, then we can say x is daughter of y. Here what we are specifying, if y is father of x, father y comma x means x is father of y, x is father of y, x is father of y and y is female, then we can say daughter x comma y. Then that is x is daughter of y, x is daughter of y. That sorry for that. I am explaining with a little confusion. Once again, I'll explain this. That complete rule is representing in the form of more general rule with the variables. Here, father y comma x is there, female y is there, then daughter x comma y. Here, what we are specifying, if x is father of y and also y is female, then we can say y is daughter of x. Y is a daughter of x. Y is a daughter of x. That we are specifying this relation as this rule as a most general rule, and this we can call as a first order representation. Here first order Haar classes may also refer to the variables in the preconditions that do not occur in the post conditions. So in that example we have specified that with the variables. These are represented as a first order rules or Hahn classes. We already know another name for the first order rules is Hahn classes, and also we can say first order Hahn classes. So in this we are representing the, we are having the one more property of these Hahn classes is whatever the variables used in precondition that may not occur, that all variables that may not occur in the post condition. Property is the variables which are used in the precondition of the Hahn class that may not occur in the post condition of Hahn class. To understand this rule and to represent this rule, here we are giving the one more example. That is here we are representing the relation of granddaughter. To represent that, here we are using the rule of more general rule. If father yz and mother zx, female y, then granddaughter x comma y. Then granddaughter x comma y. First one is if z is father of y. If z is father of y, then x is and also x is mother of z and also x is mother of z. Then if y is female, then y is female. Then y is female, then what we are giving the relation between the x and y. Here three people are there. One is daughter, one is father, one is son and mother relationship. Son and mother relationship, father and daughter relationship is there. Z is father of y. Y is female means daughter. Y is daughter of z. And x, here we are specifying one female, but we are not describing her. X is mother of z. And what is the relationship between the x and y means y is granddaughter of x, because y father is z, z mother is x. Y father is z, z mother is x. So what is the relationship between these two persons x and y is granddaughter of x. And see in this rule, whatever the variables used in preconditions what we are specifying, what are the terms are there beside if, or we can call as a preconditions. What are the terms beside the then word are called the post conditions. So here y, z, x, y, z, three variables are used in precondition, but in post condition we are using only the two variables x and y. Z is missing. So there is no need of whatever the variables present in the preconditions, or there is no need to present in the post conditions. So this is the one property. So whatever the variable which is present in the preconditions and which is not present in the post condition, that we can call as extensionally quantified. And it is possible to use the same predicates in the role post conditions and preconditions, enable the description of recursive roles. And generally, to express whatever the terms we are using in all the expressions are here, we are giving little description about that. Whatever the terms we will use to in the expressions, in all the expressions. So all the expressions are composed of constants, variables, predicates, predicate symbols, function symbols. Constants, variables, predicate symbols, function symbols. For constants examples, these are the Bob, Louis, Sharon, these are all. What are the variables? X, Y, Z, whatever we are using, that are variables. And what are the predicate symbols? It is married, greater than, that type of we can call as a daughter, married, father, these are the predicate symbols. And what are the function symbols? Age, that type of things are function symbols. And what is the main difference between the predicates and functions are? Predicates doesn't have the values. Predicates doesn't have the predicate have the values of true or false. Predicates are having the values of true or false, whereas the functions are taking on the constants. Functions are taking on the constants with their values, not the particular true or false. Predicates are taking on the values of true or false. Functions are depending upon the different values. And to represent this, we are using the notations of lowercase symbols, capitalized symbols. And lowercase symbols are using for the variables as well as for functions. For variables, functions, lowercase symbols are used. Capital symbols are using for the constants and predicates. To represent the constants and predicates, capital symbols are used. Lowercase letters are using for the variables as well as for the functions. So generally these are the terms are using to express any rule, and to within the expressions, these are the terms, terminology we are generally use. So from these symbols, we build an expression as follows. For example purpose, we are giving them an expression. A term is any constant, any variable, any function applied to any term. What is the term is? Term is a constant. It may be the variable, function or anything that we can call as a term. And we are using another terminology, literal. Literal is, it is the predicate. It may be the positive predicate or negative predicate. Positive predicate or negative predicate. That we can call as a literal. And what is positive literal and what is negative literal means, if there is any negative value, then we can call as a negation is there, negative literal. What is literal means, already we told you, that is predicate. If any negation is applied, that we can call as a negative literal. Otherwise, we can call it as a positive literal. What is literal? Once again, I am repeating, that is the predicate. What is the term? Term may be the constant, variable or function. So now we are going to know the word is class. We said first order rules are Horn classes. Before going directly to that one, we are giving the every word definition. Now we are going to know about the class. What is a class means? It is a disjunction of literals. What is literal? Literal is a predicate. What is predicate? Predicate will have the values of true or false. Predicate will have the values of true or false. And positive or negative literal, positive or negative predicate, that we can call as a literals. Any disjunction set of literals we can call as a class, where all the variables are assumed to be universally quantified. Already you know about what is the quantifier symbol and universally quantified symbol. And what is Horn class? Class is disjunction of literals. What is Horn class? Horn class is containing at least one positive literal. It is also disjunction of literals or set of literals. But at most it must have the one positive literal. Then we can call as a Horn class. So till now we learned about the simple words. What is term? What is literal? What is class? What is Horn class? And what are the what are the different terms we will use it in expressions. like variables, constants, predicate symbols, function symbols. To represent that, we are using lowercase letters, capital letters. Lowercase letters for the variables and functions, to represent the variables and functions. Capital letters we are using to represent the constants and predicates. So here we are given the Hahn class example, H, disjunction of literals, maybe the negative literals. At most it needs to contain the one positive literal. It needs to contain the one positive literals. H is the positive literal, negation L1 to negation N are the negative literals. So what are the terms we learned? So these are the basic definitions. Generally we will use it in first order logic. Already we know first order can call as a ILP, inductive logic programming. Very well formed expression is composed of constants, variables, predicate, functions. We already studied about these definitions. What is the term? Term may be the constant, variable or any function on the any term. On the any term that we can call as a term. And what is literal? Any predicate. It may be the positive or negative. What is ground literal? Ground literal is a literal that does not contain any variables. If it is not containing any particular variables, then we can call as a ground literal. And what is negator literal? If any literal containing the negated predicate, then negative literal. If it is not, doesn't have any negation symbol, that we can call as a positive literal. And what is class? Class is a disjunction of literals. And what is Hahn class? Hahn class is also one expression. It is also disjunction of literals. At most it needs to contain the one positive literal. And within the Hahn class, H is called the head or consequent of the Hahn class. Here Hahn classes are represented like this with this expression. If it is representing like this expression, with this like this expression, here in this expression, H and L1 to Ln all are having the positive literals. So if any expression is representing like this Hahn class, then H is called the head or consequent. And L1, L2 conjunction of these literals we are calling as a body or antecedents of the Hahn class. And for any literals A and B, if the expression is like this, it is equivalent to A disjunction of negation B. If the expression is like this, then we can call as A disjunction of negation B. And the expression is negation of A conjunction B. It is equivalent to negation of A disjunction of negation of B. Therefore, Hahn class can be equivalently written as disjunction of like this. Disjunction of at most one positive literal, remaining all negative literals. So Hahn class we can write like this also, like this also, like with this expression also. Otherwise, we can write as a set of literals or disjunction of literals. And substitution. Next definition is substitution. Substitution is any function that replaces the variables by terms. What is term? Term may be the constant or variable, any other function that we can call as a term. If substitution means any function that replaces the variable by other term, that we can call as a substitution. For example, the substitution x by 3, y by z. It replaces the variable x by the term 3 and y by the z. If you are representing like this, x by 3 and y by z, x is replaced by the 3 and y replaced by the z. A substitution, given a substitution theta and the literal L, we will write L theta. Given that substitution is substitution theta and the literal L, we will write it as a L theta. And to denote the result of applying substitution theta to L, applying the substitution theta to L. And what is the unifying substitution? Unifying substitution for two literals L1 and L2 is any substitution theta such that L1 theta is equal to L2 theta. By substituting with the substitution of theta on the literals of L1 and L2, then this expression these are equals. L1 theta is equals to L2 theta. That is, after the substitution, both needs to have the relationship between these two is equality. Then we can call as it is unifying substitution. So these are the basic definitions we are generally using in the first order logic, and which is equivalent to the following are using our earlier rule is notation like this. L1 A to A Ln, then H. So what is H here? H is head, and L1A2, L1ALN are called the body or antecedents. Body or antecedents. And H is we can call as preconditions or body or antecedents. Post condition is head or consequent. Head or consequent. These are antecedents. These are consequents. Now we are going learning sets of first order rules, that is FOIL. Learning sets of first order rules, that is FOIL. First order inductive learning, FOIL. Learning sets of first order rules we can call as a FOIL algorithm. It is first order inductive learning. It is very similar to the sequential covering learning one rule. We already know about the sequential covering algorithm. In that module is there, subroutine or module is there, learn one rule. And which is already know within the previous video. The FOIL program is natural extension of this earlier algorithms to first order representations. So this FOIL algorithm is simple extension for the first order representation. And hypothesis learned by the FOIL are set of first order rules only, where each rule is similar or in the form of Horn classes, with the two exceptions are there. Whatever the hypothesis we are getting by the FOIL algorithm is just like the first order rules only, first order rules representation, that is like the Horn rules only, but there are two exceptions. What are the two exceptions are? Here we are giving the two exceptions. The hypothesis learned by the FOIL are sets of first order rule, where each rule is similar to the Horn classes, with the two exceptions I already told you. First exception is the rules learned by the FOIL are more restricted than the general Horn classes because the literals are not penetrated into the contained function symbols. This reduces the complexity of hypothesis space. Whatever the rules learned by this are more restricted, with the FOIL algorithm is more restricted than comparing with the general Horn classes. By that, it reduces the complexity of searching the hypothesis space. So whatever the exception it is having FOIL algorithm, that is giving the one advantage. That is, it is reducing the complexity of hypothesis space search. And the second exception is FOIL rules are more expressive than the Horn classes. More expressive than the Horn classes. What is Horn class? What is class? What is literal? What is term? Now only we covered all these things. We need to remember that one. So FOIL rules are more expressive when comparing with the Horn classes. Because literals are generally appearing in the body of the rule, maybe the negated or positive. So that's why FOIL algorithms advantages FOIL by this second exception is it can be applied to the variety of domain problems. For this simple example for this is quicksort algorithm, and in chess positions we are making that illegal chess. We are finding legal positions or legal moves from the illegal chess positions. So these are the real-time applications with this FOIL algorithm. So FOIL algorithm has the two exceptions than the Horn classes. By using that two exceptions, it has the two advantages. So in this FOIL algorithm, outer loop, inner loop, two loops are there. Outer loop is corresponding to the variant of sequential covering algorithm. That means it learns the new rule one at a time by removing the positive examples which are covered by that particular rule and applying iteratively on the remaining examples to learn the one more rule. And what is inner loop corresponding to it is the variety of our learn one rule algorithm. Learn one rule extended to accommodate the first order rules. And also there are few minor differences between the FOIL and these type of algorithms. So FOIL seeks only the new rules that predict when that literal is true. That means it is going to learn or going to add the one more rule to set of rules when it is going to predict the target literal is true only. That means it is considering only the positive training examples which are having the target concept value true only. And whereas the previous algorithm, sequential covering algorithm, which is used by the learn one algorithm or learn one module, within that it is covering the both positive and negative training examples. There also it is covering maximum positive examples only, but whereas FOIL is covering only the positive examples. Only the positive examples. And foil performs the simple hill climbing search rather than the beam search. It is performing hill climbing search, not a beam search. So here we are giving the foil algorithm. See, the basic foil algorithm here we are giving in this slide. So the specific method for generating the candidate literals and definition of foil gain are given in the what is foil gain, that we are going to define once again. The basic algorithm can be modified slightly to better accommodate the noise data. So whatever the steps we said previously, for that there is little modifications are there within this within this algorithm which is shown on the slide, because why we are modified means to cover the noisy data also. So here foil target predicate, predicates, examples are there. Target predicate means target concept, whatever the literals we are giving with predicates with the values, that we are predicates, and what are the examples which are having the target concept value also, that are the examples. So PV is representing the positive training examples, that is its target predicate is having the value of true. And negative, what is NEG means these are the examples in which target predicate value is false. Learned set of rules we are starting with the empty, because at the starting when we are going to apply this algorithm, the set of learned rules are empty set only. After that, applying one type of iteration, it may add the one rule within that within the required number of iterations, we will get the set of rules that we can call as a Horn class or hypothesis, final hypothesis. So first we are with the while the training example or target example given is positive, then go for this. Learn a new rule. First start to learning a new rule. What is the new rule? The rule that predicates the target predicate with no preconditions. The rule that predicates the target predications with no preconditions. Already we know what are the. If it is a negative training example, go for the new rule with the negative. While new rule is negative, do this one. First starting with the new rule is with the positive. If it is a rule is negative, then go for this. Add a new literal or specialize in new rule. The candidate literals generate the candidate new literals for the new rule based on the predicates. Best literal is which is having the foil grain with the new rule, and add the best literal to the preconditions of the new rule. New rule negative is subset of new rule negative that satisfy the new rule preconditions. Next we are going from coming out from the all the negative rules are there, negative training examples. So after that it is coming out from the while new rule negative to again new rule positive. Then whatever the rules new rule is learned with the positive training example that are added to the learned examples. So till it covers, till it iterates till it covers the all the positive training examples. So what are the learned rules are there? It is giving only the positive training negative rules, the positive training example rules, and whatever the negative training examples we are getting, we are finding that new rule negative only within this loop, but it is not adding to these learned rules. So the most differences between the substantial differences between the foil and other earlier algorithms. Generally, what are the other earlier algorithms we learned is sequential covering, learn one rule algorithms. So what are the main differences is, in its general to specific search, general learn each new rule, foil employs different detail steps to generate the candidate specializations of the rule. The difference follows from the need to accommodate variables in the preconditions. So first difference is, it is following the general to specific only, and foil employs different types of steps. That means it is need to accommodate the variables in the preconditions also. Next one is, foil employs the performance measure, that is foil grain. This difference from the entropy measure shown for the learn one rule. So within the sequential algorithm, within the learn one rule, we are using the measure entropy there. Here we are using foil gain as a measure point to measure the performance. So foil seeks only the positive training examples, and it covers only the positive training examples. Whenever the negative training examples are there, then it will sends to the inner loop, and it will whatever the rules finding with the negative training examples, that is added to the new rule neg only. And whenever the positive training examples are there, then goes with the outer loop of the while, and it forms the new rule and adding to the previous rule. So this is about the FOIL algorithm. This is about the FOIL algorithm. With this, we know about the FOIL algorithm. What are the differences between these FOIL algorithm and the previous algorithms, and what are the exceptions are there? What are the advantages are there? What are the limitations are there? That are also we covered within this video. We'll meet in the next video. Thank you.